Take 50,000 square feet. Use it to create a clean environment with fewer than 75 particles per cubic foot of air. Install a high-tech airflow system. Add 600 operating and support people covering 3 shifts a day, 7 days a week, 52 weeks a year. Then dress them in bunny suits that cover practically everything and prevent contamination of almost anything. Have them process 5-inch wafers utilizing 0.9 to 0.3 micron technology in 200 to 300 steps. The result? Quality communication semiconductors manufactured in Allentown's largest and most modern silicon wafer fabrication room, MOS V. Built in 1984, rebuilt and expanded in 1996, MOS V is a primary player in the manufacture of integrated circuits by Lucent Technologies Microelectronics Group. MOS V, MOS for metal oxide semiconductor, 5 for being the 5th MOS cleanroom. Cleanrooms are designed for cleanliness, and MOS V is a Class 10 cleanroom. This means that no more than 75 particles per cubic foot of air are permitted. Particles that are no bigger than 0.2 microns, more than 100 times smaller than a human hair. To keep the room clean, air is constantly circulating from the ceiling to the floor, forcing particles out of the air. That's because one particle on a device can destroy it. That's also why cleanroom dress is so important. In MOS V, people wear a hood, face mask, full coverall garment, shoe covers, safety glasses, and gloves. They don't wear makeup or hairspray. The goal is to prevent particles from falling onto the product. These bunny suits are made of 100% polyester fibers with carbon fibers intertwined to eliminate static electricity. They are inspected regularly. High-tech dress in a high-tech room ready to make high-tech products. That's what MOS V is all about. And it all begins with wafers. MOS V gets its silicon wafers from the Silicon Materials facility here at Allentown. There, silicon ingots are grown, sliced into wafers, and polished. Here, in MOS V, wafers are fabricated in a repetitive process where each wafer is sent through 6 major processing areas multiple times. The exact number depends on the design of the wafer, which is created by designers based on the function that particular product is expected to perform when completed. Wafers coming into MOS V are segregated into lots, identified, and sent on to the chemical area to be cleaned. A wafer must first be rid of any foreign particles or impurities, such as sodium and metals, before it can be processed. Next comes thermal oxidation, as well as low-pressure and plasma-enhanced chemical vapor deposition. In thermal oxidation, oxygen reacts with the silicon surface on the wafer to form silicon dioxide, which prevents implant or diffusion of dopant into silicon and isolates one device from another on the wafer. Dopants, which are impurities that make the silicon more conductive, will be added later. Then, chemical vapor deposition allows thin films to be deposited onto the wafer. These provide conducting regions within the device, electrical insulation between metal, and protection from the environment. MOS V uses low-pressure chemical vapor deposition and plasma-enhanced chemical vapor deposition. Material used includes polycrystalline silicon, silicon dioxide, stoichiometric silicon nitride, and plasma-deposited silicon nitride. The wafer then heads to photolithography, where circuitry is patterned onto each chip of the wafer. The process works like this. First, an ultraviolet light-sensitive material called photoresist is spun onto the wafer. Then, within a step-and-repeat facility, a reticle with the design pattern is placed above the wafer, and ultraviolet light is flashed through the mask onto the wafer, exposing the resist and chemically changing its makeup. Next, developing solution is placed or puddled onto the wafer. This removes the exposed resist, uncovering the underlying film and transferring the reticle features onto the wafer. The pattern process is repeated many times in a stepper, The reticle pattern is transferred by stepping across and down the wafer. The widths of the resulting defined lines and windows are measured to ensure the design specifications are met. These patterns are not permanent elements, but only replicas of circuit features. They must be transferred or etched into the layers of the device to produce circuit features. This is done with reactive plasmas, discharges in which ionization and fragmentation of gases takes place. Thus, the name of the process, plasma etching. Next, in metal deposition, a thin layer of metal is sputtered onto the wafer. The metal film is then patterned, providing electrical connections between contacts on devices, similar to wiring a house. Up to 3 levels of metal are deposited. In the ion implantation area, dopant ions, the impurities that make the silicon more conductive, are vaporized, accelerated, and implanted onto the surface of the silicon dioxide. This method controls the number of implanted dopant ions, thus controlling the electrical characteristics of the device. Making sure wafers get from one point to the next at the right time in the right order to meet the needs of the next customer is a challenge, but one that is thoroughly met by the systems we have in place. Process control tracks all work in progress. LWIP, level work in process, helps balance the load throughout the room. Our select system prioritizes the work in queue and helps the operator select the next lot to be processed. And our maintenance tracking system and preventative maintenance systems work to assure that cleanroom equipment is up and running, preventing delays costly to us and our customers. Throughout the manufacturing, quality is paramount. Our quality policy, customer delight through continuous improvement, is applied to everything we do. In MOS V, monitoring occurs continually. Process control charts used to determine when tweaking is necessary to optimize product quality and reliability are automatically displayed when attention and corrective action is required. If, for any reason, questionable processing occurs, the material is designated as non-conforming and is separated from normal product until a resolution is made. Allentown is registered to ISO 9001, an international quality standard, and to ISO 14001, an international environmental standard. Being continuously certified to these standards ensures that our manufacturing processes and products meet rigorous criteria and expectations. After leaving our cleanroom, the devices will be tested and packaged. The result? Leading-edge integrated circuit devices used in most advanced high-tech products, computer hard drives, modems, corded and cordless telephones, mobile phones, answering machines, and switching and network equipment. MOS V products go to the largest and most influential customers in the high-tech world, traveling around the globe from the Lehigh Valley. MOS V, leading Lucent Technologies microelectronics group in its goal to be the best semiconductor company in the world. The company our customers most admire, desire, and require. MOS V, helping microelectronics remain the world leader in communications semiconductors.